Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 12 of 21. Merging two massive tables together is the single most expensive operation in distributed computing. Apply the wrong matching logic, and it becomes the easiest way to crash your cluster by running out of memory. Knowing exactly how to combine datasets safely is what when DataFrames collide, the art of joining is all about. The primary mechanism for combining data in PySpark is the join method. You call this on your base data frame, passing in the data frame you want to attach, the specific column or columns to match on, and the join method. If you provide no join method at all, PySpark defaults to an inner join. Consider a concrete scenario. You have one data frame recording people's heights and a second data frame recording their incomes. Both datasets share a column called name. With an inner join, PySpark looks at the name column in both datasets and only keeps rows where the name exists in both places. If a person appears in the heights data but is missing from the incomes data, their record is completely dropped from the result. To retain unmatched records, you change the join type. A left join keeps every row from your starting data frame, which in this case is the heights data. If PySpark finds a matching name in the incomes data, it appends that income. If it does not find a match, it keeps the height row but places a null value in the income column. A right join performs the exact inverse, keeping all incomes and padding missing heights with nulls. When you need absolutely everything, you use a full join. PySpark retains every record from both data frames. Matching names are merged into a single row, and any names existing in only one dataset are kept, with null values filling in the missing data from the other side. Here is the key insight. A cross-join operates differently because it ignores the join condition entirely. It pairs every single row in the heights data frame with every single row in the incomes data frame, creating a Cartesian product. If both tables have just 1,000 rows, a cross-join outputs 1 million rows. This explosive growth is why cross-joins are heavily restricted by default and often require an explicit configuration to execute without throwing an error. The final two join types are actually filtering operations rather than true data merges. A left semi-join looks for matches, returning rows from the heights data frame only if the name also appears in the incomes data frame. The crucial difference from an inner join is that a left semi-join does not pull over any columns from the right side. You're left with the exact same columns you started with, just filtered down to the records that have a corresponding match. A left anti-join does the precise opposite. It returns rows from the heights data frame only if the name does not exist in the incomes data frame. It drops the right side columns entirely. This makes the left anti-join the most efficient way to identify missing data or find records that failed to process downstream. The choice of join determines not just what data you get back, but how much data has to physically move across your network to generate the result. Thanks for tuning in. Until next time.